Hello again, I'm Al Boudreau, and I'd like to welcome you again for another one of our series on the wonders of astronomy. Today we're going to be looking at nebulae and star clusters. This is in celebration of the International Year of Astronomy 2009. We're celebrating this global event, and the theme is the universe yours to discover. And this is particularly an invitation for you to go to a star party or an astronomy meeting or something like that and celebrate this International Year of Astronomy, celebrating the 400th anniversary of the date in which Galileo first turned a telescope towards the skies. Now today we're going to be looking at some of the most beautiful things in the cosmos. We're going to be looking at these beautiful nebulae that are out there in space, glowing and providing these beautiful colors. And we're also going to be looking at star clusters, and we'll describe what each of these things is and how you can probably see one of these at a star party when you go. Now, last time we looked at the planets, and we looked at the planets all the way from Mercury on out to the Kuiper Belt. Now, in this presentation, we're going well beyond our solar system. We're going way out into the cosmos, beyond the distance even of the closest star to us. So we're going quite a ways out. In fact, we're going out so far that we're going to be out here in the section of our galaxy that we live. We live in a galaxy just like this, a combination of stars, and in the next presentation next week we'll actually be looking at galaxies. But for the time being, let's just remember that we live in a island of stars just like this. We're about 26,000 light years out, and I'll explain what a light year is in just a second. And we're going to be looking at just our neighborhood in this area to look at these nebulae and star clusters. Now, what is a light year? Well, light travels at an astonishing speed of 186,000 miles a second. If you took a flashlight out at night, pointed it up to the sky, and flashed it into the cosmos, that beam of light would travel out at 186,000 miles per second and continue out until it hits something. This is the tape measure that we use in astronomy. So what we measure is actually that distance that light travels in an entire year, an entire Earth year, which turns out to be 5.8 trillion miles. That's quite a distance. 5.8 trillion miles. A trillion is 1,000 billion, so it's quite a large number. Now we're going to be looking in this area here from about, I would say, 700 to about 10,000 light years. It's actually beyond the nearest star cluster, the Hyades. We'll be looking at that, of course, but most of these nebulae are out in this range right here. It's not out as far as the other galaxies. All these are within our own galaxy, but basically in this range here. Now, nebulae, these are, to me, some of the most beautiful things in the cosmos. And this is the one that you often see in many pictures. This is the famous Orion Nebula that we see each winter. It's a beautiful cloud of dust and gas that is producing new stars. That are about over 100 new stars being born right now in this one cloud. Now, these nebulae come in three varieties, and we need to understand that. As you see these pictures, I want you to appreciate what you're really looking at. First of all is the reflection nebula. This is simply that the particle of gas or dust is acting like a mirror and reflecting the light that's hitting it. And they usually appear blue in these pictures, as you can see here. The other type is emission nebula. In an emission nebula, the gas itself is actually emitting the light. And I'll show you how that happens. It's quite an interesting process. And usually those appear red, as you can see here. The other type is an absorption nebula. In this case, it's just simply a very dark, dense cloud that's not letting any light at all come through it, and so it appears black. And you can see some dark dust lanes in here, and we'll see some more as we go on. Now here's a good example, the Iris Nebula. This is a primarily a reflection nebula. You can see it's mostly blue. What is happening in this case, there's some very young, very hot blue stars, and they are emitting their light, illuminating the gas, and the gas is simply reflecting that light back to us. This particular one is located 1,300 light years away from us in the constellation of Cepheus. And notice the size of this thing. These things are huge. We normally think of a cloud as being something rather small and something we can contain. But these things actually measure in light years wide. So they're tremendous in size. Now here's another beautiful one. This is called the Cocoon Nebula. Here you can see that we have a lot of emission shown here in red. We have a streak here, blue, where the gas is reflecting the light. And we also see these dust lanes in here. These dust lanes are very dark absorption clouds where no light is coming through to us. This is located in the summer constellation of Cygnus the Swan, and it's located about 4,000 light years away from us. Now here's, I think, my favorite Absorption Nebula. This is called the Horsehead, and I think you can see why it's called the Horsehead. And here we have some gas in the background emitting reddish light. We have a reflection nebula down here, but we have this very dark cloud here that's not emitting any light at all, and it happens to be in the shape of a horsehead. So this is the famous Horsehead Nebula. It's located very close to the constellation Orion the Hunter. It's a winter constellation. This particular one is located 1,500 light years away from us in that beautiful constellation of Orion. Now here's a good example of a pure absorption nebula. Early on, astronomers thought that these might be holes in space, simply holes where there were no stars at all. We now know that that's not the case. These are simply very dense clouds that happen to be out there and blocking the stars in the background. So there are stars in the background all through here, but we can't see them because of the density of this. Now this particular cloud is 500 light years away, and it's about 1/2 of a light year across. So it's pretty large. Now, I have one technical slide in this presentation, and I hope you'll bear with me here, because many people say, how in the world can this gas, this very thin gas out there in space, possibly emit light all by itself? So I have to explain how that happens. And it's the hydrogen atom that primarily does this. A hydrogen atom, as you know, is the simplest of all the atoms. It has one proton in the center and one electron that's zipping around the outside of it. Now normally, for a normal hydrogen atom, that electron likes to zip around in what we call the ground state, this lowest orbit. However, now and then, a hydrogen atom will get close to a very hot star that will be emitting UV radiation. This is a very intense UV radiation, and when it does that and it hits that hydrogen atom, it kicks it up to a higher state. So in this case, I might, if you pretend for a moment that I'm that hydrogen electron out there, and I get hit, and I'll be jumped up to a higher state. And then I get hit again, and I get up yet a higher state, up to the 3rd level. Now, I don't like it here. The electron likes to be down there at that lower level. But there's only one way I can get down there, and that's to emit some energy. And I emit that energy in the form of a red photon of light. So when I emit that energy, I can then come down to the lower level. So that's what's happening in this gas. The gas is being bumped up to a higher energy level by this UV radiation. And then in trying to get back down, it has to emit energy in the form of red light. It can also jump down to lower levels from the 4th level all the way down to the 2nd level and emit a green photon as well. So it's not only red, but sometimes green. This is what we call the hydrogen alpha decay, where we emit this red photon. And so many of these red colors that you'll see are the result of this process. Now you may think this is kind of an odd process, but actually this is the same process that's used in all your fluorescent light bulbs. The same process of kicking an electron up to a higher energy level and then let it relax and emit some light. Now here's a beautiful example. I call this H-alpha light gone wild. This is the Rosetta Nebula, and it's just a beautiful example of this emission of light by this gas. And notice the size of this thing. This thing is 25 light years across. These clouds are just immense. We just cannot imagine in our own minds, at least in my mind, I can't get my head around the size of this thing. 25 light years across in this picture right here. Now here's a beautiful nebula called the Trifid Nebula. Now you'll see in this case we have an emission area. It's surrounded by a reflection area in blue, and then we have these lines here of absorption right in the middle, making this beautiful picture that looks something like a flower. This particular one is 5,000 light years away from Earth in the constellation Sagittarius, which is a summer constellation. And this thing is relatively young. It's only 300,000 years old, which in astronomy time is just a baby. So it just was recently formed. Back in the year 1054, this was before I was born, but 1054, people around the Earth saw this bright new star appear. It was what we call now a supernova. At that time they didn't know exactly what it was. They thought it was a new star, and it shone very brightly for a number of weeks and then finally faded away. Today, if we look at that spot, and we know exactly where it was because the Chinese astronomers in particular were very meticulous about pointing out exactly where this was. So we know exactly the location. If we go there today, we find what we call the Crab Nebula. This is the result, the leftovers of that supernova, when that giant star exploded and threw out most of its material into space. It created this beautiful cloud of heavy materials. These are where our very heavy elements are created in these supernova explosions. So this is one you'll be able to see. It's called M1, or the Crab Nebula. And perhaps this summer, if you go out, you'll be able to see that through a telescope. Now here's another one I like. This is called the Eskimo Nebula. And I think you can see why this is called the Eskimo. Here's the face and the surrounding hood of the Eskimo. This is photographed by the Hubble Space Telescope. Many of these nebulae have interesting shapes that we've named just because of the way they happen to look. Now here's one I think you can see. This is called the witch's head. I think you can see the eyes, the nose, the mouth, and the chin. This particular one, as you can tell, is a pure reflection nebula. Off to this picture ways is Rigel. It's a very bright blue supergiant star, and that's the star that's illuminating this particular again, Rigel is in the constellation of Orion, so this would be a winter constellation, a winter nebula. Now here's another interesting one. This is the Californian Nebula. As you can see, it somewhat resembles the state of California. This one here is called the North American Nebula. You can see Florida down here, the Gulf of Mexico, and the rest of North America and Central America down here. So astronomers like to name these things after the shapes that they have. Here's an interesting one. This is a bubble, a giant bubble in space as a result of a star emitting a large amount of material out in a bubble form. This is in Cassiopeia, which is a constellation. Here in Vermont, we see that constellation all year around. Right now, it's pretty low on the horizon, but in the summertime, it'll be getting up to a higher altitude. So this bubble is just sitting there, but the amazing thing is the size of this thing. Where it looks pretty small to us, is 10 light years in diameter. That bubble is 10 light years in diameter. And you can imagine how large this cloud is that's surrounding it then. Here's a category of nebulae that we call Planetary Nebula. Now, we call them planetary. Early on, astronomers used to think, back in the 1800s, they used to think that these were somewhat associated with planets, but now we know they're not. They have nothing to do, absolutely nothing to do with a planet. So although they're called planetary nebula, just ignore that idea. They have nothing to do with planets. What they are the remnants of a dying star. A star about the size of our sun, when it dies, rather than go in supernova, will simply shed its outer layers. And it will shed them often in terms of a ring such as this. So this is the famous Ring Nebula. It's a summer constellation. It's in the summer constellation Lyra, and you'll be able to see this. Lyra, the harp. You'll be able to see this, and you'll be able to perhaps even make out that tiny little star that's left over. What we find left over is what we call a white dwarf star. It's a very small star, about the size of the Earth. There's no longer any nuclear reactions taking place. It's just sitting there glowing. All its outer shell has been shed in a beautiful ring such as this. Sometimes, as I said, these stars go through a series of convulsions. They're not always nice and rounded like this. Oftentimes, they'll go through a series of convulsions, and you can see here in this particular one, it's quite obvious that this thing went through a number of convulsions, and we'll see in some of the other ones of these planetary nebula, they often go through some very odd expulsions of this material. And this gas is traveling out away from the star at about 50,000 miles an hour. So these things don't last too long. They'll last 100,000 years to maybe 1 million or 2 million years, and they're gone. So in astronomy time, that's very brief. So we just happen to be at the right place at the right time in order to see these. Here's one of the most beautiful, I think. This is called the Helix Nebula. Again, it's another big ring of material, and you can see that little white dwarf there in the middle. This is shedding that material. That material is slowly going away from the star, and eventually it will be so far away from the star that it's no longer illuminated by that star. This particular one is very close to us. In fact, it's the closest of the planetary nebula. It's only 700 light years away from Earth. This is one I love. This is called the Cat's Eye Nebula. As you can imagine, this star, as it started to go through these convulsions, didn't go through regular convulsions, but went through a series of very odd convulsions, leaving this beautiful pattern behind. So this particular one is going to be very short-lived. They think it will last only about 10,000 years. But right now, the material is close enough to the dying star right here that it is illuminated, and we can see this beautiful pattern. Now, I warn you, if you go to a star party and you look through a telescope, you will not see anything that looks like this. Typically, you'll see something that only looks gray. That's because these are pictures that are taken through telescopes such as the Hubble Space Telescope over a period of hours of exposure. That's how we get these beautiful colors to come in. Your eye looks at things at about 1/30th of a second for each exposure. So when you look at it, you're going to be looking only with the rods of your eyes, which are not color sensitive. So you'll just see something that looks gray. You won't see these beautiful colors in there. This is one that I like. It's called the Butterfly Nebula, and I think you can see why it's called the butterfly. Oftentimes when these stars die and they start to shed the material, they'll shed a large, very dense ring of material around themselves, and then that material will block further emission of the material, so the material can only go out in two directions. So it goes out this way and that way. And this happens quite a bit. We call these bipolar planetary nebula, or directional nebulas. And there are quite a few of them out there. Now here's another one. This is called the Ant Nebula. Again, the same principle. There's a large torus of very dense material that's blocking the material from going out in anything other than two directions. And so we have this bidirectional emission of the material from that star. Again, these are stars about the size of our sun that are dying, in the process of dying and shedding their outer layers of material. Here's one I like. This is called the red rectangle. Actually, it's not a rectangle at all. What you're looking at is looking at two cones. One cone is coming out this way from the star, and the other cone is coming down this way. And we're looking sideways through those cones. Those cones are semi-transparent, and we're looking through the cones. So as we look sideways through the cones, it kind of looks like a rectangle, but it actually is not. It's two cones. Again, there's a constriction around the center of that star that's forcing the material out in only two directions. This is one I bet you've seen. If you ever go out on the internet, you've probably seen this sent around many times. They're often called the Eye of God. This is a echo, essentially. This star here in the middle had a flare-up in 2002, and it shot out a bright beam of light, and that light came out and it started to reflect and bounce around this cloud of material that was already out there. That material has been out there for eons, and the light finally reached it and started bouncing around this. But this is a very transient thing. It will be visible only until next year, in 2010. This particular one is located 20,000 light years away, and this was taken by the Hubble Space Telescope. Now, to show you the transient nature, the next slide here will actually give a time sequence. Here it is in May of '02. You can see it's basically just a little round ball here. Then the light goes further out into the cloud in September '02. Finally, in October, it has that shape that we've come to see and appreciate, December '02, and finally February '04, and you can see it's beginning to fade here. And by next year, it will be completely gone. So many of these nebulae are very transient phenomena. They just don't last very long at all. Here's one that's a little different. This is actually a star, a very large star, called Eta Carotene, that is about to go supernova. It's about to explode, and when it does explode, all those heavy elements will be shot out into space. This is kind of a preview. What we see here, these giant lobes of material, are a preview, an initial ejection of material, but it's not the supernova itself. So we are anxiously looking at this. This happens to be in the southern hemisphere, so normally we here in Vermont cannot see this particular one. But this is about to go supernova any time now, and I certainly hope it does so within my lifetime. Now, many times astronomers won't look at these nebulae only in one particular wavelength of light. We like to look at them in different wavelengths because each wavelength tells us something a little bit different about that material. Now, this is a composite picture here of a supernova remnant, and it's a combination of the Chandra X-ray Observatory, which is a satellite in orbit, along with the Hubble Space Telescope and the Spitzer IR telescope, also in orbit. The combination of those three together create this beautiful composite, but they also carry a great deal of information. As we look at each one individually and then look at them together, we can tell a lot more about this particular one and how it's formed, how it's emitting radiation. In this case, there are actually emissions from this in X-rays as well as IR. And so not only that red light that we saw before, which is visible, but also in IR all the way to X-rays. Now, I said we were going to stay within our own galaxy, but Actually, this is located in a satellite galaxy called the Large Magellanic Cloud, which is very close to us. So I personally consider it somewhat part of our galaxy, since it is rotating around and orbiting our own galaxy. And this is another remnant, a supernova remnant in that cloud. And as you can see, they're quite beautiful, quite large. This is the Lagoon Nebula. This one is located 5,200 light years away, and again you can see a lot of reflection and surrounded then by a lot of the emissions. And all these clouds are star forming areas. New stars are being born in these giant clouds all the time. So every day a star dies, and every day a star is born. This is one of my favorites. This is the Flame Nebula, and as you can see here, very bright emissions here, and in the middle of that there's this very dark dust lane of absorption right there. Now, we've been talking about nebulae, and as I said, stars are born in these clouds. And here's a beautiful example of a large emission nebula, very dense, and you can see some of these spires here. These spires are stars actually coming out of that cloud. And here we have what we call a star cluster, an open star cluster. This particular star cluster then emerged from the cloud, and as it emerged and the stars lit up, the radiation from those stars tended to push that gas away. Now these particular stars are grouped together at the moment, but as they continue to go around our galaxy and rotate around our galaxy, they'll tend to spread out and lose their identity as a star cluster. Our own star, the Sun, probably was in a group such as this when it was initially born. And our star has now gone around, rotated around our galaxy about 18 times. So it lost its identity in those 18 circuits around the center of the galaxy and is now not associated with any particular group. But here we have a bunch of young stars just coming out of their birth cloud, and so they're still grouped together. And this kind of grouping is what we call an open star cluster. And you'll probably see many of these if you go out to a star party and look through a telescope. Now, as I said, those stars are born in these very dense clouds. We call them molecular clouds in that they contain molecules of hydrogen, helium, and some of the heavier elements as well. These clouds are huge. This is particular picture is from the Hubble Space Telescope. You can see these little arms here, these little modules coming off. Our entire solar system could fit inside the tip of one of these things. That's how large these are. These are huge, absolutely huge. And new stars are being born every day in such clouds. Now, as I said, it's very difficult to get your head around the size of these things. I have a difficult time even imagining a light year, let alone many light years. Here, these jets coming out of this particular cloud, as you can see here, each one of those is a light year long, an entire light year long. It's 5.8 trillion miles. You know, it's just hard to imagine the size of these clouds. And here's an open star cluster. As I said, this is a group of stars that emerged from their birth cloud. They're still hanging together, so it's been only recent, probably in the last few 100 million to 1 billion years that they emerged, and they're still together. They will slowly, very slowly, over time, drift apart and lose their identity as a star cluster. This particular one is called M39. It's in Cygnus the Swan, which is a beautiful summer constellation. And this one's located 800 light years away. The stars in this we think are very young. It's only about 300 million years old. So they're quite young yet and haven't had a chance to dissipate. Now here's another one. This is the Hyades, and this happens to be the closest open star cluster to us. Now this bright star here is Aldebaran. It's only 60 light years away, and it's actually not part of this. The Hyades cluster is actually 150 light years away in the constellation of Taurus. So this is the closest one to us, and this one also eventually will lose its identity as an open star cluster. Now there's another type of star cluster you may see, particularly if you go and look at the summer constellation of Hercules. You'll see the giant globular cluster in Hercules. These are quite different than the open star clusters. This is an association of 100,000 up to perhaps 1 million stars, all grouped together in one huge ball. And here's an example of one right here. And these balls are quite large. They're 100 to 200 light years in diameter. They're just fantastic in size. And they actually don't orbit within the plane of the Milky Way galaxy, but they orbit around it, and oftentimes will go right through it. We think they may be actually the remnant or the core of a small galaxy that at one time got swallowed up by the larger Milky Way galaxy, and all that's left are these little remnants. There are about 150 of these that now circle around the outside of our galaxy, and they're beautiful to see. And when you look at them, you actually won't be able to discern individual stars in the center. They're so closely packed together. So a lot of people say, well, don't they crash together? No, they don't. Actually, although from our perspective they look very close together, they're actually far enough apart, but so they very seldom will actually collide with one another. This completes our story of nebulae and star clusters. The next time we are going to be looking at that fascinating topic of galaxies. We live in a galaxy. Our own sun orbits around the center of a galaxy. Every 250 million years we orbit the center of our galaxy. So we'll look at these fascinating things, and we'll see how we've discovered billions upon billions of them out there. So I think you'll really enjoy this. It's one of my favorite topics for sure. Now, I'd like to once again invite you to go on your computer to these websites. The website for the Vermont Astronomical Society, that's located in Burlington. It's at vtastro.org, and the Southern Vermont Astronomy Group at silvera.org. And there you can find announcements for future meetings. You can also find announcements for star parties. Star parties typically cannot be planned too far in advance, so you'll have to watch the websites very closely to see if you can actually go out and attend one on a particular night. If you have any questions for me, you can reach me at astromanvt@gmavt.net. Thank you, and hope we'll see you again soon for Galaxies.